Good day, and you're very welcome to this Saturday's technical session of the CNPS. I do hope wherever you are, the audience, the spring weather is fine, and the countryside is smiling as it is here in Ireland. We're getting wonderful weather, and I hope it's also very sunny wherever you are. Today, we're very happy to have Vladimir Netchitailo return. He's presented, he's presented to us on a number of occasions before, and he's also spoken actually at the Sunday sessions on cosmology, which are hosted by Harry Ricker. But today he's concentrating on his world universe cosmology, which is abbreviated WUC, which he's spoken about on a number of occasions. And he's basically saying, well, in general, in the global sense, WUC presents a transformative cosmological framework that challenges and revises the standard Big Bang model. Now, that's quite revolutionary. It could be music to the ears of many of us. It makes us prick up our ears. He's challenging the major standard idea of the cold, dark matter Big Bang system. So what he says is WUC presents a transformative cosmological framework that challenges and revises the standard Big Bang model. So we just use WUC for the world universe cosmology and BBM for the Big Bang model. By addressing and resolving key paradoxes in contemporary cosmology, WUC offers a fresh perspective on the origins, evolution, and structure of the world. Now that's very important because, you know, there are many, many theories out there and they just may be wild ideas. We want something which addresses the basic information we have and performs sort of the role of giving us a rational description of what probably went before. We were just looking at something, actually, I think Harry sent out just shortly, just a while ago, about does the universe spin? That's a new idea. Well, the idea is if the universe is everything, how can it spin? What's it spinning relative to? So that's an example of sort of seemingly absurd, if I may say so, ideas coming out here. Now, just one thing, if I may, very briefly, I want to give as much time because, as usual, Vladimir will be speaking for roughly an hour, and then we'll have roughly an hour for questions and answers and more detailed discussions among people in the green room. And we have one or two spaces left, I think, in the green room. So just very, very briefly, I'll not labor this, but the 2025 fund driving endeavor of the CNPS is still active, and it's reached, I think, just over 50% of its goal. So it's still open. I'll not present the large video, which we did for the first few months of 2025, but basically, in summary, fund.naturalphilosophy.org will help, and if you might consider looking at that, it would help considerably. We're really in the long term ensuring that this organization survives, because of the outlay on the servers and the various other endeavors and publications and so on. We're all volunteers. We don't get paid or anything like that. But the organization just it has a little shortfall, and it is helpful to get small contributions. So anybody who's contributed already, much thanks. Okay, so I think it's time we start. Both our creationists, Big Bang versus small puff. Yeah, okay, just a comment. Okay, well, it's my pleasure to introduce Vladimir, who's always a very cogent speaker. And in fact, he makes sure, sort of belt and braces, as we say, he has his presentation there in detail and text. He's going to project that up, and he's going to read to it as well. So, Vladimir, good day to you, and very welcome.
Hello, everybody. Thank you for coming.
Yeah, well, we're all ears. We're always delighted to hear your talks. And in fact, personally, I'm delighted to have been in the position last summer of hosting 8, I think it was, of your presentations in which you went through all the details. So there are still many questions that people have, and I think a sort of a more general talk today on how you offer fresh perspectives on the origins of the universe and so on and so forth, and your whole idea about well, it's not called dark matter anymore. You would explain this yourself. I don't want to steal your thunder, but you call it world created matter or something, don't you? So I'll let you do that. And we're already getting very positive comments. Vladimir is very knowledgeable and so on. So Vladimir, I'm going to I'm going to ask you, we did this a second ago actually in trial, just to put your slides up so I can pop them up there. You see, you did that in a second. You're a
yes,
hand.
I will do it now. Don't worry. It's a presentation.
Then I'll give you the floor. I'll disappear myself.
Okay.
Now the thing is up, and all I'll do is I'll allow you to introduce things, and I might then, with your permission, just possibly maximize the text and maybe bring your photograph off. But anyway, and if you need me, just call me. I'll be out of the equation, so it may take a moment or two to come back. But your voice will be audible all the time. So the floor is all yours, Vladimir, and just call if you have any questions at all.
Hello, everybody. Thank you for coming. Today, during 1 hour, I will try to tell you the review of my model that I have developed for 24 years. As Ian told me, the last year I gave you 8 different presentations about different issues. It was 8 hours talks and 8 hours discussion. Today I will try to tell you about the maximum points and the most critical points of my model, because it's very difficult to have a review during 1 hour and to report to you 24 hours of my life. World Universe Cosmology proposes a comprehensive theoretical framework that critically re-examines and extends beyond the standard Big Bang model. By systematically addressing persistent anomalies and unresolved paradoxes with contemporary cosmology, WC offers an alternative paradigm for understanding the origin, large-scale structure, and dynamic evolution of the cosmos. Key innovations of World Universe Cosmology. No Big Bang singularity. WC rejects the idea of an initial singularity, t equals 0, and instead envisions the eternal universe that continuously generates new matter in the world. This concept bears similarities to Fred Hoyle's steady-state theory, which posits that while the universe expands, its large-scale structure remains unchanged over time. In this view, the universe has neither a beginning nor an end, requiring a continuous creation of matter to maintain a constant density. As Hoyle stated, by introducing continuous creation of matter into the field equations of general relativity, a stationary universe showing expansion properties is obtained without recourse to a cosmical constant. Creation process is likely to be of an essentially quantum character. While WC shares key features with the steady-state theory, such as the eternal universe, elimination of initial singularity, continuous matter creation, it introduces fundamental differences, including the first, a distinct concept of the beginning of the world. The second, a unique mechanism for matter creation. The third one, a decreasing energy density of the world involves the expansion of the world's nucleus in the fourth spatial dimension, leading to the stretching of the hypersphere world. These distinctions set what WC apart as a novel framework for understanding cosmic evolution beyond the classical steady state model. The finite, boundless world, unlike Big Bang models, practically infinite universe, WC describes the world as the hypersphere of the four-dimensional nucleus. It introduces a patchwork quilt structure of the observable world, where major superclasses form in different regions at different cosmological times. Emergent gravitation. Departing from general relativity, WC explains gravity as an emergent phenomenon arising from weak interaction between universe-created particles and matter, aligning with the Lissajous mechanism of gravitation. Time and cosmological evolution. WC introduces cosmological time, a continuously progressing parameter governing the evolution of primary cosmological parameters, including the gravitational and Hubble's parameters, both of which are inversely proportional to cosmological time. Matter creation and galactic formation. Rather than originated from a primordial inflation, galaxies, stars, and planets emerge through an ongoing process of universe-created matter production. This innovative approach resolves several key gaps in understanding the world's evolution, paving the way for a more comprehensive cosmological paradigm. Hypothesis revisited in the framework of WC. A notion of physical ether was first proposed by Isaac Newton in 1675. Subsequent investigations by Thomas Young and Augustin Jean Fresnel in 1816 led to the prevailing view that light propagates as a transverse wave within an elastic medium termed the luminiferous ether. It was recognized early on that such an ether could not be constituted of ordinary elastic matter, which transmits only longitudinal waves. In 1846, James McCulloch advanced a theory describing a rotationally elastic medium, wherein potential energy of deformation depends solely upon the rotation of volume elements, rather than their compression or distortion. McCulloch's theory yielded equations formally analogous to Maxwell equations and demonstrated that a medium with such properties could support the transmission of transverse waves. Despite these developments, the concept of the luminiferous ether was ultimately abandoned following the advent of special relativity in 1905. Nevertheless, prominent physicists continued to advocate for the existence of an ether. Nikola Tesla in 1937 asserted, "All attempts to explain the workings of the universe without recognizing the existence of the ether and indispensable function it plays in the phenomena are futile and destined to oblivion." Similarly, Paul Dirac, in his 1951 publication, "Is There an Ether?", argued for the necessity of an ether to underpin physical theory. In this context, the cosmic medium proposed by WC can be interpreted as the modern revival of the ether concept, intended to restore classical foundations within cosmology. Lissajous kinetic theory of gravitation, initially formulated by Nicolas Fatio de Duller in 1690 and later explained by Georges-Louis Lesage in 1748, posited a mechanical explanation that streams of particles, termed the ultramundane corpuscles, bombard material bodies from all directions. Partial shielding between two bodies would then result in a net imbalance of pressure, effectively driving them together. Lesage hypothesized that these corpuscles originate from beyond the known universe. It's a very critical point. Within the WC framework, this classical concept presently anticipates the role of all ultra-relativistic universe-created particles, which I named psions. In 1783, John Mitchell became the first to theorize the existence of dark invisible stars, suggesting they could be detected through the gravitational effects within binary star systems. This insightful prediction was substantiated nearly 2 centuries later with the discovery of Cygnus X1 in 1971. Bernard Riemann in 1854 proposed modeling finite universe as a hypersphere, the surface of four-dimensional ball, which is the nucleus of the world in WC. WC extends Riemann conception, proposing that the world is evenly stretched as the result of the expansion of the nucleus along its fourth spatial dimension. This approach obviates the necessity for dark energy to explain cosmic expansion. Within WC, the cosmic medium and macro objects composed of stable elementary particles are posited as the fundamental constituents of the hypersphere world. The rotational fission hypothesis, introduced by George Darwin in 1879, sought to explain the moon's origin via a rapidly spinning proto-Earth wherein centrifugal forces at the equator nearly balanced gravitational attraction. Gravito-electromagnetism, an analog to electromagnetism with a gravitational theory, was first formalized by Oliver Heaviside in 1893. His equations, while different from Maxwell's equations by specific constants, represent an extension of Newtonian gravitation into a dynamic field theory. It is a very important critical point. In the early 20th century, William Duncan Macmillan proposed a steady-state cosmological model, suggesting that a balance between stellar matter energy conversion and the spontaneous creation of atoms from radiation could preserve large-scale cosmic features. Although Macmillan didn't propose a mechanism for atom creation, his ideas presaged aspects of the later Bondi-Gold-Hoyle steady-state theory. James Jeans, in Astronomy and Cosmology in 1928, hypothesized a steady-state universe facilitated by the continuous creation of matter from an external spatial dimension, fourth spatial dimension. He proposed that the centers of nebula might function as singular points through which matter entered our universe. This conjecture strikingly foreshadowed the WC model, wherein universe-created particles transport newly created matter from the four-dimensional nucleus into the hypersphere world. Jeans also critically analyzed the Laplacian nebula hypothesis, arguing against the formation of planets and stars from a single gaseous cloud due to centrifugal instability. Nobody put attention to this conclusion of him. Paul Dirac's large number hypothesis and hypothesis of variable gravitational constant in 1937 later incorporated the notion of continuous matter creation within the universe in 1974. Furthermore, Paul Dirac extended Mach's principle in 1938, asserting that local physical laws are determined by the large-scale structure of the universe. In 1983, Paul Wesson introduced the five-dimensional space-time math theory, wherein the fourth spatial coordinate is associated with the rest mass of particles, and the gravitational constant acts as a dimension transposing parameter. As summarized by Overdoing and Wesson in 1994, matrix independent of the additional spatial coordinate generate massless induced matter, photons, and all other particles, whereas matrix dependent on this coordinate yield equations of state for massive particle fluids. WC identifies the nature of this fluid, the cosmic medium, as consisting of massive particles, protons, electrons, photons, neutrinos, and UC particles. Thus, the WC framework re-examines and integrates numerous historical concepts, many of which have been overlooked or marginalized within mainstream cosmology. By synthesizing classical ideas with novel hypotheses, WC endeavors to construct a unified, coherent, and simplified model of the cosmos. Why fourth spatial dimension world? WC introduced the concept of the hypersphere world to address the absence of the center of expansion in 3D universe associated with initial singularity. In frames of WC, the center of expansion resides in the center of the four-dimensional nucleus. The expansion of the nucleus causes the stretching of its surface, which constitutes the hypersphere world. There is no need for dark energy. Creation of matter is the direct consequence of the nucleus expansion in the fourth spatial dimension. Creation of UC particles occurs homogeneously in all points of the hypersphere world. Overdoing and Wesson postulated that metrics which depend on X4 give back equations of state for fluids composed of massive particles. WC supplies this fluid cosmic medium. In WC, the fourth spatial coordinate is associated with total energy of the observable world. The eternal universe continuously generates ensembles of UC particles which resemble air vortices with angular momentum. According to WC, all parameters of the world depending on a dimensionless time-varying quantity Q, which is the ratio of radius r to a basic size unit A, and is in fact Dirac's large number, are a manifestation of the world's curvature in the fourth spatial dimension. Leveraging the interconnectivity of primary cosmological parameters revealed by WC, we demonstrate that the gravitational parameter G experimental, which can be measured directly, enables the determination of all other cosmological parameters that are not directly measurable. Using G experimental, we calculate the radius of the curvature R as follows. From G experimental, we can calculate Q experimental and then find R as a multiplication of A on Q experimental. And this R is about 10 to the power 26 meters. Principal points of WC. Beginning. The world was started by a fluctuation in the eternal universe, and the nucleus of the world, which is the four-dimensional ball, was born. An extrapolated nucleus radius at the beginning was equal to the basic size unit of A, about 10 to the minus 14 meters. The finite boundless world is the hypersphere of the four-dimensional nucleus. All points of the hypersphere are equivalent. There are no preferred centers. Stretching of the world. The four-dimensional nucleus is expanding along its imperceptible four-spatial dimension so that the radius of the nucleus R is increasing with speed c, a gravitodynamic constant that is identical to the electromagnetic constant c in Maxwell equations, resulting in the even stretching of the world. Creation of matter. The surface of the nucleus is created in a process analogous to sublimation. Continuous creation of matter is the result of this process. Sublimation is a well-known process that happens when surfaces are intrinsically more energetically favorable than the bulk of a material, and hence there is a driving force for surfaces to be created. The universe created matter in the four-dimensional nucleus. Universe created particles carry new UC matter into the world. Ordinary matter is a byproduct of UC particles' self-annihilation. The proposed four-dimensional process is responsible for four-dimensional nucleus expansion, the world stretching, creation of matter, an arrow of time, which doesn't depend on any physical phenomenon in the world. It is the result of the nucleus expansion due to the driving force for surfaces to be created. It constitutes the prime hypothesis of WC. Creation of UC matter occurs homogeneously in all points of the world. Content of the world. The world consists of the cosmic medium and macro objects. Total energy density of the world equals to the critical energy density calculated using Hubble's law in my model throughout the world's evolution. The energy density of cosmic medium is 2/3 of the total energy density, and macro objects 1/3 in all cosmological times. The relative energy density of UC particles is about 92.8%, and ordinary particles about 4.8% in cosmic medium and 2.4% in macro objects. The cosmic medium is the absolute frame of reference. Homogeneous and isotropic cosmic medium, consisting of protons, electrons, photons, neutrinos, and UC particles, is an active agent in all physical phenomena in the world. WC belongs to classical physics. In WC, classical notions can be introduced only when the very first ensemble of UC particles was created at an extrapolated cosmological time, about 10 to the minus 18 seconds, and the notion cosmic medium can be introduced. The finite, boundless hypersphere world is the container of cosmic medium and macro objects. Classical physics deals with ensembles of quantum objects. Time, space, and gravitation relate to the impedance, gravitomagnetic parameter, and energy density of cosmic medium, respectively. It follows that neither time, space, nor gravitation could be discussed in absence of cosmic medium. There is no cosmic medium. There is nothing. Cosmological time, tau, marches on at a constant pace from the beginning of the world up to the present epoch, along with time-varying cosmological parameters, including Hubble's parameter H, which are inversely proportional to tau. H is equals to tau minus 1. the value of H should be measured based on the cosmic microwave background radiation data only. Rotational fission, the mechanism that can provide angular momenta to macro objects, is the rotational volcanic fission of overspinning surface space at equator exceeding escape velocity prime objects, which are transferring some of their rotational angular momentum to orbital and rotational momentum of macro you see method of superclusters, which must accumulate tremendous rotational angular momentum before the birth of a luminous world. It means that it must be some long enough time in the history of the world, which we named dark invisible epoch. The eternal universe provides the angular momentum to prime objects through the flux of UC matter along the four spatial coordinate of the nucleus of the world. Dark invisible epoch spans from the beginning of the world, 14.226 billion years ago, to 0.44 billion years for Laniakea supercluster, that is the home of the Milky Way galaxy, when only UC matter macro objects existed. Luminous epoch has lasted ever since 13.787 billion years, when luminous macro objects emerged due to the explosive volcanic rotational fission of overspinning UC matter superclusters cause. It looks like a firework of UC matter cause of satellites at the same time. So the direction of the sum of satellites' angular momentum coincides with the angular momentum of the prime object. There are no preferences of directions of satellites' rotation at any level, galaxies, extrasolar system versus random rotation direction. UC matter cause of prime objects detonate at critical points of their stability. Observable world is the three-dimensional Hubble bubble with the radius r equals to 14.226 billion light years. Two fundamental parameters in various rational exponents define all macro and micro features of the world. Dimensionless Rydberg constant alpha that equals 2a r infinity in power 1/3, that is named the fine structure constant now, and r infinity is the Rydberg constant, and time varying quantity q that equals about 10 to the power 40, that is the Dirac's large number. We stress that the best theory is the one which is based on the minimum number of dimensionless parameters. According to WC, the following parameters depend on Q: Newtonian parameter gravitation, Hubble's parameter, age of the observable world, the radius of the nucleus of the world, critical energy density, concentration of intergalactic plasma, minimum energy of photons, temperature of microwave background radiation, temperature of fine infrared background radiation peak. You see how many parameters we can calculate based on Newtonian parameter of gravitation only. In WC, local physics is linked with the large-scale structure of the hypersphere world through the dimensionless quantity Q. The proposed approach to the fourth spatial dimension agrees with Mach's principle. Local physical laws are determined by the large-scale structure of the universe by Q. Applied to WC, it follows that all parameters of the world depending on Q are a manifestation of the hypersphere world's curvature in the fourth spatial dimension. All physical laws are determined by cosmic medium, which is both homogeneous and isotropic. Indeed, the cosmic medium emerges as the cornerstone of classical physics, a savior of its principles. According to WC, we can use the well-known equations considering time-varying physical parameters. Let us not discard this profound concept, cosmic medium, with the tide to modernity. We must not throw the baby out with the bathwater. What happens in 1905? Universe created particles. Observable world consists of particles of ordinary matter, protons, electrons, photons, neutrinos. On the other hand, there are particles created by the universe, you see particles, of a new kind of you see matter, which have following characteristics. You see fermions or bosons, rest energies, take a look on table 1, weak interaction, and self-annihilation, like Majorana fermions. Ordinary particles are a byproduct of UC particles' self-annihilation. It is worth noting that the rest energy of electron equals to alpha multiplied E0, and the Rydberg unit of energy equals to half alpha cubed multiplied on E0, where E0 is a basic energy unit that equals to 70 mega electron volts. Considering these two well-known equations, the main goal of WC, two-dimensionless parameters only, alpha and Q, we propose for UC particles the values of rest energies which must be constant, created by the universe, and therefore are proportional to rational exponents of alpha. See table 1. WC proposes multi-component UC particles consisting of two couples of co-annihilating UC particles. A heavy fermion UCF1 with 1.3 tera electron volt and light spin 0 boson Dirac 70 mega electron volts. That is a dipole of Dirac's monopoles with charge mu equals E over 2 alpha, E an elementary charge. A heavy fermion UCF2 with 9.6 giga-electron volt rest energy, and a light spin 0 boson LO 340 kilo-electron volts. That is a dipole of preons with electrical charge E over 3. Fermions UCF3 3.7 kilo-electron volts, UCF 4.2 electron volts, and boson xions 5.3 micro-electron volts. All of them presented in this table. You see, particles are dark, optically invisible when astronomers investigate observable world with telescopes only. The contemporary astronomy allows us to investigate observable world on wavelengths from radio waves up to gamma rays. Then they are not dark at all. John Mitchell was the first person known to have proposed in 1783 the existence of dark stars. He proposed that astronomers could detect dark stars by looking for star systems which behaved gravitationally like two stars, but where only one star could be seen. It was an extraordinary, accurate prediction of binary systems. The first known binary star system with optically invisible partner was Cygnus X1 in 1971. That is typically the rays with energy to 60 kilo-electron volt. It's not dark at all. In 2000, Mitchen et al. Discovered binary galaxy system, Virgo HI21, with NGC 4254 galaxies, which has a 21 centimeter emission. There are no black holes in WC. The reason for this multi-component UC particle system was to explain the diversity of very high energy gamma ray sources in observable world. The diversity of UC matter caused of macro objects in observable world, superclusters, galaxies, and extrasolar system, which are fermion compact objects, and UC matter reactors fueled by UC particles. The signatures of UC particles self-annihilation with predicted rest energies are found in spectra of diffuse gamma-ray background and the emission of various macro objects in observable world. These two kinds of matter have different origin of radiations. Ordinary particles radiate electromagnetic waves by electron outside nuclei. UC particles radiate gamma rays, which are emitted by nuclei as a result of self-annihilation of UC particles with rest energies covering 18 orders of magnitude, as I showed you in table 1. Dirac's monopole, it's a very important issue for physics. In 1931, Paul Dirac demonstrated that if magnetic monopoles exist anywhere in the universe, then electric charge must necessarily be quantized. Since electric charge is indeed observed to be quantized, this finding is consistent with, but does not conclusively prove, the existence of monopoles. According to WC, the quantization condition arises from the presence of particles Dirac, which are conceptualized as dipoles formed by Dirac's magnetic monopoles. In this view, the so-called auxiliary magnetic field intensity H represents the current density of these magnetic dipoles. This interpretation provides a possible explanation for large-scale magnetic structures such as the Milky Way magnetic field, the dark magnetic field, and other magnetic phenomena that are only partially correlated with matter visible in conventional spectral ranges. These effects could arise from the motion and distribution of Dirac's dipoles throughout space. It's a very important issue. It means, what does it mean, magnetic field? Movement of particles Diracs. Gravity. In WC, the time-varying gravitational parameter G is proportional to the energy density of cosmic medium. It is not constant. That is why WC aligns gravity with Lesarge's theory of gravitation. Lesarge proposed quantitative estimates for some of the theory's parameters and called the gravitational particles ultramundan corpuscles because he supposed them to originate beyond our known universe. It was a genius prediction of universe-created particles, xions, in WC that gives for Lesarge's theory following parameters. Xions, 5.3 microelectron volts rest energy, are ultra-relativistic UC particles, ultramundan corpuscles, which created by the universe. Proposed weak interaction between xions and UC particles and ordinary particles of macro objects provides mass proportionality. Energy density of xions in the world is about 64% of the total energy density and provides high intensity of their flux. We emphasize that the gravitational mass is a classical notion that defines gravity emergent phenomena. An inertial mass that is a coefficient between a force and an acceleration has nothing to do with it. It's summary of the calculated by WC in 2013 cosmological parameters and measured parameters are presented in the following table. We have in parameters gravitational, Hubble's, ionized baryons, minimum photon of energy, microwave background radiation temperature, fine infrared background temperature peak, absolute age of the world. The calculated numbers in 2013 was done only by WC. No, never, nobody, never model could calculate these values with such accuracy. These values were measured in different years later or even before the WC model. But what is important, compare the calculated value and measured value later, how close they are, And even this very important microwave background radiation temperature was measured in 2009, and there is no any other choice. We don't have any other calculations of this temperature. Take a look how close the calculated value with the measured value earlier than WC. We emphasize that WC allows for precise calculation of values that were only measured experimentally earlier and makes verifiable predictions. The discovery of supermassive compact objects at the center of our galaxy, Nobel Prize in Physics 2020, made by Genzel and Gass, is the confirmation of one of the most important predictions of WC in 2013. Macro objects of the world have cores made up of the discussed dark matter, UC matter particles. Other particles, including dark matter and baryonic matter, form shells surrounding the cores. TWCT discoveries in 2022-25 confirmed the most important predictions of WC in 2018. Absolute age of the world is 14.226 billion years. Dark invisible epoch spanning for the Laniakea supercluster from the beginning of the world for 0.44 billion years, when only UC matter macro objects form and evolve. Luminous epoch ever since 13.787 billion years, when luminous macro objects, superclusters, galaxies, extrasolar systems emerge. Transition from dark epoch to luminous epoch is due to explosive volcanic rotational fission of always spinning UC matter superclusters cores and self-annihilation of UC particles. Macro objects of the world form from the top superclusters down to galaxies and extrasolar systems in parallel around different cores made up of different UC particles. It's a principally different point against Big Bang model. Problems explained by WC. WC solves a number of problems in contemporary cosmology through UC particles and their interactions. Angular momentum problem in birth and subsequent evolution of galaxies and extrasolar systems explained by explosive volcanic rotational fission of overspinning UC matter superclusters cores. Missing baryon problem related to the fact that the observed amount of baryonic matter didn't match theoretical predictions solved by the calculation of the concentration of intergalactic plasma. Fermi bubbles, two large structures in gamma rays above and below galactic center, are stable clouds of UC particles, UC fermion 1, 2, and 3, containing uniformly distributed UC matter objects in which UC particles self-annihilate and radiate gamma rays. Galaxies are ellipticals and spirals due to explosive volcanic rotational fission of their overspinning UC matter cores. Coronal heating problem relates to a question of why the temperature of the solar corona is millions of degrees higher than that of the origin of the solar plasma is not coronal heating. Plasma particles, electrons, protons, multi-charge ions are so far apart that plasma temperature in the usual sense is not very meaningful. Plasma is the result of the self-annihilation of UC particles. The solar corona, made up of UC particles, resembles a honeycomb filled with plasma. Let me remind you that the size of solar corona is about 10 times more than diameter of the solar itself, of the sun itself. Cores of suns and Earth rotate faster than their surfaces, despite high viscosity of the internal medium. WC explains the phenomenon through the absorption of UC particles by UC matter cores. UC particles supply not only additional mass proportional to tau in power 1.5, but also additional angular momentum proportional to tau squared. Cores irradiate products of self-annihilation, which carry away excessive angular momentum. Solar wind is the result of this mechanism. Internal heating of gravitationally rounded objects in the solar system is explained by UC matter reactors inside of all macro objects fueled by UC particles. Internal heating is due to UC particle self-annihilation. Diversity of gravitationally rounded objects in the solar system is explained by UC matter reactors inside of macro objects fueled by UC particles. All chemical elements, compositions, and radiations are produced by macro objects themselves as the result of UC particle self-annihilation in their different UC matter cores. Plutonium-244, with half-life of 80 million years, exists in nature for 4.6 billion years existence of solar system. It is not produced by a nuclear fuel cycle because it needs extremely high neutron flux environment. Any plutonium-244 present in the Earth's crust should have decayed by now. In WC, all chemical products of Earth, including isotopes gallium-40, uranium-238, thorium-232, and plutonium-244, are produced within Earth as the result of UC fermion-1 self-annihilation. They arrive in the crust of Earth due to convection currents in the mantle carrying heat and isotopes from the interior to the planet's surface. Faint young sun paradox describe the apparent contradiction between observations of liquid water early in Earth's history and the astrophysical expectation that the sun's output would be only 70% as intense during that epoch as it is during the modern epoch. In WC, all macro objects of the world were fainter in the past. As their UC matter core absorb new UC particles, the sizes of macro objects that are proportional to root square of tau, and thus their luminosity, are increasing in time proportionally to tau. Considering the age of the world, about 14.2 billion years, and the age of the solar system, 4.6 billion years, it is easy to find that the young sun's output was 67.6% of what it is today, compared with the expected 70%. Matter-antimatter asymmetry problem. Ordinary matter is a byproduct of UC particle self-annihilation. This problem does not arise since antimatter is not created by UC particle self-annihilation. Black body spectrum of cosmic MBR is due to thermodynamic equilibrium of photons with intergalactic plasma. Solar corona, geocorona, and planetary coronas made up of UC particles resemble honeycombs filled with plasma particles, electrons, protons, or multi-charge ions, which are the result of UC particle self-annihilation. Ball lightnings are objects that have cores made up of UC particles surrounded by electron-positron plasma shells, contaminated by chemical elements of soil and air as the result of terrestrial gamma-ray flash strikes off the ground. WC predicts a new phenomenon, a generation of ball lightning according to the proposed model. Once we master their creation in a controlled environment, we can concentrate our efforts on harvesting that energy from a practically infinite source, the cosmic medium of the world with UC particles. Wave-particle duality dilemma. It's a very important issue. In physics, the observer effect refers to the disturbance of a system caused by the act of observing it. A well-known illustration of this occurs in quantum mechanics, particularly in the double-slit experiment. When the path of a particle is observed, the characteristic interference pattern, typical of wave behavior, fails to form, highlighting the principle of wave-particle duality. Richard Feynman famously emphasized that the behavior seen in the double-slit experiment is impossible, absolutely impossible to explain in any classical way. I believe him, underlying that this mystery lies at the heart of quantum mechanics. However, according to WC, the notion of wavelengths is a classical concept rather than a fundamental quantum property. In this view, wavelengths is a characteristic of an ensemble of quantum objects, such as photons, each of which individually possess a four momentum but no intrinsic wavelengths. Thus, under WC, wave-particle duality is not a fundamental feature of quantum objects. Instead, wavelengths emerges collectively from ensemble of particles. Under this framework, the act of observation, using detectors, for example, disturbs the ensembles of particles, causing the emergent wavelengths and thus the interference pattern to disappear. This explains why, when the path of the particle is measured in the double-slit experiment, the interference pattern vanishes. Furthermore, we draw attention to an inconsistency in the Big Bang model's explanation of the cosmic microwave background radiation. According to Big Bang model, the photons present at the time of photon decoupling, approximately 380,000 years after the Big Bang, have continued to propagate through space. Over time, as space expanded, the wavelengths of these photons stretched, making them fainter and less energetic. The photons we observe today in the MBR are supposedly the same photons from that epoch. However, this interpretation appears to contradict the results of the double-slit experiments. If each photon inherently had a wavelength, then that interference patterns should persist even when the paths of the protons are observed. Yet, experimentally, when the particle's path is directed, no interference patterns forms. Another miracle, the axis of evil, refers to a controversial correlation between a plane of the solar system and certain anomalies in microwave background radiation. Specifically, the motion and orientation of the solar system's ecliptic plane appear to align with certain features observed in microwave background radiation. Unbelievable. After 380,000 years, microwave background radiation knew about existence of solar system. In WC, the black body spectrum of MBR is explained by the thermodynamic equilibrium between photons and the intergalactic plasma, the existence of which has been experimentally supported by observations of fast radio bursts. The solar wind, which consists of charged particles, primary protons and electrons, emitted from the sun's corona, has a plasma density distribution that varies with distance from the sun. Radial distribution. Close to the sun, about 0.1 astronomical unit, the particle density is high, ranging from 100 to 1000 particles per cubic centimeter. On Earth orbit, 1 astronomical unit, the density averages between 5 to 10 particles per cubic centimeter. Beyond 1 astronomical unit, the distance reaching as low as 1000 particles per cubic centimeter, between 80 to 120 astronomical units, before rapidly increasing near a heliopause to 0.2 particles per cubic centimeter. Latitude distribution. Near the solar equator, the solar wind is denser and slower, known as the slow solar wind, with speeds of 300-500 kilometers per second. At higher latitudes, near the sun's poles, the solar wind is faster and less dense, referred to as the fast solar wind, with speeds of 700-800 kilometers per second. This distribution of solar wind plasma exhibits cylindrical symmetry relative to the plane of the ecliptic. The interaction of photons from ambient air with this plasma may account for some of the anomalies associated with the axis of evil. No miracles. Interaction with plasma. Hubble tension. The Hubble tension refers to the significant discrepancy in the measured values of the Hubble constant, H0, which defines the rate at which the universe is expanding. Different methods yield conflicting results. Measurements based on microwave background radiation data suggest a lower value of H0, while those relying on observations of type 1a supernova in nearby universe indicate a higher value. Recent observations using both GWST and the Hubble Space Telescope have confirmed that this tension is not due to the measured error. According to Rees, with measurement errors negated, what remains is the real and exciting possibility we have misunderstood the universe. You see how it's critical. A Nobel Prize laureate in physics Rees named it. In framework of WC, the Hubble tension is interpreted differently from the standard Big Bang model. In standard cosmology, Hubble's law assumes that all galaxies originated from a single point, the initial singularity, implying that tracing their motion backwards in time leads to an infinitely dense state at t equals 0. However, this assumption is challenged by WC, which proposes that galaxies are gravitationally bound with their respective superclusters and did not originate from a single point. According to WC, the observable world is a three-dimensional patchwork quilt of luminous superclusters, more than about 1,000, each emerging at different locations and cosmological times. This framework better accounts for the observed redshift variations among galaxies. For example, the redshift of the center of the Laniakea supercluster is measured as Z equals 0.0708. However, this does not mean that it is receding from Milky Way. Instead, it is the Milky Way that is moving within the supercluster. Some galaxies within Laniakea are moving toward Milky Way, blue shifted. while others are moving away, redshifted. Thus, redshift is relative and depends on the galaxy's position and motion within its supercluster. This situation becomes more complex when considering galaxies in adjacent superclusters. Supporting this, in 2009, Gupta reported the discovery of over 8,300 blue-shifted galaxies located beyond the local group. Notably, the Andromeda galaxy, the nearest major galaxy to Milky Way, is also blue-shifted. Nobody explained why. Standard cosmology struggles to comprehensively explain such findings. Under the WC framework, the Hubble constant should be derived solely from the cosmic microwave background radiation data. The calculated 3 kilometers per second per megaparsec NBR data 78.6 plus minus 1.3 kilometer per second per megaparsec. Most direct observational evidence of validity of WC. Cosmic microwave background radiation, intergalactic plasma, and the far-infrared background radiation all provide compelling evidence for the existence of the pervasive cosmic medium, a foundational component of WC. The Laniakea supercluster, with a binding mass about 10 to the power 17 mass of the Sun, encompasses the Milky Way and 100,000 neighboring galaxies. The spatial distribution and motion of these galaxies indicate they did not originate from a common initial singularity, challenging the standard Big Bang assumptions and favoring the framework proposed by WC. The Milky Way is gravitationally bound to the Virgo supercluster, and it possesses significant orbital angular momentum, estimated based on a distance of 65 million light years and an orbital speed of about 400 kilometers per second. The orbital momentum greatly surpasses the galaxy's intrinsic rotational angular momentum. The mass-to-light ratio of the Virgo supercluster is about 300 times that of the solar value, consistent with values observed in other superclusters. Such high ratios support the existence of vast amounts of universe-created matter, a key element of WC. Astronomers have discovered the most distant known galaxies, JADAS GS Z14-0, about 13.5 billion light away, less than 300 million years, as well as F200 DP045, a candidate galaxy located at 13.7 billion light years, less than 100 million light years after the Big Bang. These discoveries push the observational limits of the world and reinforce the need for a comprehensive cosmological model like WC. The cosmic medium, universe-created matter, and angular momentum form the three pillars of WC. To the best of our knowledge, WC is the only cosmological model that inherently aligns with the law of creation and conservation of angular momentum, offering a coherent and observationally grounded alternative to prevailing models. Conclusion: WC is consistent with all fundamental concepts of the observable world. The model successfully describes primary cosmological parameters and their relationships allowing for precise calculations of values that were previously determined only through experimentation. Moreover, its verifiable predictions and remarkable agreement with observational data reinforce confidence in its validity. Rather than claiming to explain all cosmological data or presenting a fully developed theory, it serves as a foundation for a new cosmology, one originally envisioned by Paul Dirac in 1937. While further refinement by the global physics community is essential, WC insights combined with the groundbreaking discoveries of GWST and Dirac's proposals over the past 87 years underscore the need for a fundamental transformation in astronomy, cosmology, and classical physics. World Universe Cosmology invites recognition. Thank you very much for your patience. Your questions.
Well, I have heard Vladimir speak a number of times, and he never disappoints. He's very, very clear, and he's reading slowly through, quite a complex position paper. And thank you very much. You didn't really go over the time, actually, because I was speaking. I took about 10 minutes at the beginning to introduce you and say a few other things. So thank you very much, Vladimir.
I tried, as always, try to be on time.
Yeah, I know. You're very precise. You're very precise there. There's a few things before maybe we have a quick look at the questions. I did put a comment into them. I didn't want people to stop talking between themselves, but they seem to be doing that a lot, and I wasn't sure if there were questions. So maybe I got an indication. Maybe some people had said questions. So I think there are a few questions we may go through, and then we can have a bit more of a discussion with the few people in the green room. Well, I'm not going to take much time trying to summarize or anything like that, but I'd just like to say that Vladimir has introduced a number of historical elements, which I think can be very illuminating, and many people may not know these things. Like, he talked about the fundamental earlier work of McCulloch, which to a certain extent led to Maxwell's work. And, he introduced John Mitchell's work on dark stars and so on. I think that's very important as well. The fundamental particles, which I didn't quite have the terminology for in the introduction, obviously he's talked a bit about the UC particles, universe created particles, I think. I was also struck by, you might think it's a minor thing, but it's very important to be logical. A lot of populist stuff going out there is not logical. And, it's very important to realize that the converse of a proposition isn't always true. So if A always implies B, that doesn't mean that B always implies A. Well, I'll give you one example where that comes out in Vladimir's work. He was talking about the Dirac, I think, proposal that magnetic monopoles would require the quantization of charge. And then he says, well, charge is quantized by observation, and that is consistent with the existence maybe of magnetic monopoles, but it doesn't by any means prove it. So he's given that very, very logical. You might have missed that, but I was impressed with that when it went through. And the other thing is obviously WUC leading to these fundamental constants, which we have talked about in a number of respects. So that's quite impressive. And finally, he's addressed things like the Hubble tension and the axis of evil in terms of theory, and indeed, the conception that it is really explicatory of the conservation of angular momentum, which perhaps is not explained otherwise. So before handing it over, I'll just maybe ask one thing of Vladimir at present. If he could maybe be very brief. I know he's very clear on these, but because I think a number of people might not understand the difference between Vladimir's conception of stretching and the more common expansion of the universe. So maybe just if you could just maybe contrast those for some people who might be confused, Vladimir, it would be appreciated.
It's very simple. Expansion supposed to have a center of expansion. But if there is no center, there is no expansion. Simple like this. And to imagine, it's very simple. Take an air ball and push it, and you will see extension of the size of the bubble, and you can see the stretching of the surface of this bubble. Simple like this. That's why it's a very simple explanation, the difference. Stretching, there is no need in center. Center of expansion is in the center of the nucleus of the world. But in the Big Bang model, there is no center of expansion. How you can talk about the expansion? And even what is the expansion in the practically infinite notion of expansion? Expansion of what? We know that their calculation is 93 billion light years diameter of the universe. An expansion of all of it or of some of it, of what? Even this one doesn't, I don't understand it. That's why, this notion of Big Bang model, very unclear for everybody, including myself. It's unclear. In my case, it's a very simple. You have center of expansion of nucleus, and you have your stretching of the surface of this ball. That's it. Simple like that.
And I think if people have that concept in their minds as they're addressing these questions, it will be useful. Thank you very much.
But nobody, by the way, used stretching before myself, because that's why I insist on this definition. Stretching. There is no expansion, no center of expansion, no expansion. Expansion of the infinite universe, I don't understand it. In my case, it is finite, boundless world, and there is a stretching of it. By the way, it's analog to inflation. You see, they are talking about some stretching, maybe some kind of stretching during inflation up to 93 billion light years for 10 to the minus 34 seconds. Can you believe in such speed of stretching? It's unbelievable. Thank you so much for very good, important point, but I have so many critical points different from Big Bang models. It's a totally different model.
Okay, that's important. Actually, Quest has come in, I think, with a few questions on the 4D nucleus. There might be a few further down. We might be able to deal with them all in one fell swoop. He's just saying, isn't the 4D nucleus sort of similar to the initial singularity, at least in the sense that it caused the beginning of the universe?
No, I will tell you why. Because the critical point, initial singularity, has all the matter of the universe at once. And this is an infinite energy density and all this stuff. In my case, no, we have our production of matter in this four-dimensional nucleus from the very beginning. From the very beginning, there is no comparison even with initial singularity. Matter, we have creation continuously by internal universe, continuously creation. We have new galaxies, new stars, only because we have a new matter. And source of this matter is eternal universe.
Okay. Boris again is difficult for me to pronounce that. Why this background radiation is all over the place and not at a specific point? I don't know why he thinks maybe that might
background
follow.
Radiation. What is the background radiation?
Probably the CMBR, I'd imagine.
Microwave background radiation.
Yeah, yeah.
Near background radiation.
Microwave,
Microwave
yeah.
background radiation, because it belongs to cosmic medium. And it's homogeneous, isotropic, and there is a homogeneous isotropic distribution of intergalactic plasma. And MBR, microwave background radiation, that is in thermodynamic equilibrium with intergalactic plasma. By the way, it's a very important issue. You cannot get black body radiation without matter. It should be thermodynamic equilibrium between photons and some kind of matter. Photons, they cannot change their momentum. They cannot do anything about exchanging even the energy between them. They are not interacting with each other. They should have some interaction with matter, and only then it will be thermodynamic equilibrium of matter with intergalactic plasma, with microwave background radiation.
I think this matter came up before in our cosmology discussions, but Quest has raised it again. He's asked, I suppose, why you call it the cosmic medium rather than the ether. It seems very similar to certain ether theories, such as Lesarge's idea of a medium where particles travel into all directions. You shy away from using the term ether.
It's like an ether. But what is important? What does it mean, ether? Nobody never answered. What is composed of? Of what? Ether, like a liquid, it's not a liquid at all, because the medium is so low. We have only we have one proton per 4 cubic meters. How we can name it ether, liquid, perfect liquid, if the distance between protons about 4 meters at least? That's why cosmic medium differs from ether only, that I saturated this cosmic medium with particles, real particles, with real behavior, with real physical phenomena like fast radio burst and all this stuff. That's why cosmic medium is totally different from ether. It can be, you can see it like an ether, but it's not an ether. It is the medium with real particles. I named them.
So I'm not sure if this is a logical sort of non sequitur or something, but he's saying if the cosmic medium is composed of protons, electrons, photons, neutrinos, and such, if such particles exist within the how is it? If such particles exist within the cosmic medium, why don't they all get mixed up with each other? He's saying if the cosmic medium is composed of all these particles, and yet if such particles exist within the cosmic medium, why don't they all get mixed up?
I don't understand. They're all of them mixed up, homogeneous and isotropical. That's it. I agree with it. It's mixed up. This is a mixture. Cosmic medium has mixture of particles. By the way,
they're mixed, but they're not integrated.
They are not integrated. They are interacting with each other. Protons, they interact with electrons. We have intergalactic plasma. You see particles, universe created particles, they interact with each other and they radiate gamma rays and so on and so on. It doesn't mean that they're dead. They interact with each other, but the mixture of them, homogeneous and isotropic, in the overall cosmic medium.
Okay. I'm getting towards the end of these questions now. Obviously, some will probably come in while we're talking with the green room people, but just a few more moments and we'll finish these. Okay. I'm not quite sure if this is specifically addressed to you, because there was some conversation about this earlier, Vladimir, but he's saying, when are you going to clearly explain explosive rotational volcanic fusion? Do you know what he's getting at there?
Fusion or volcanic fission.
Fission.
Okay. It's different word and different meaning. I'm sorry.
Right. Yes.
First of all, volcanic. We have volcanic on our Mother Earth every day, every time. We have hundreds of them, and even more. This volcanic on the sea, That's why. What does it mean, volcanic? It's obvious. The second point. What does it mean when it will start from this dark matter or universe created matter course? They can start when you have the speed at the equator more than escape velocity. Because volcanic in our Mother Earth, they can create some stones, some lava, everything what we have right now, but it belongs to Earth. And only if you will have the surface rotation speed more than escape velocity, these parts can evacuate from this volcano and go to the space. Simple like this. And this is exactly the meaning of this process. Volcano with speed of the surface more than escape velocity. Then all the products of these volcanoes may escape and go to the space.
That's how it gets out. Yeah. So maybe on this 4D, he's basically saying, Chris, did the 4D nucleus generate everything in the complete universe? If so, how?
Everything on the contrary. The universe creates 4D nucleus. The eternal universe, there is nothing except creation of matter. This is no space, time, no physical laws. No, there is only one property, creation. We can name the eternal universe creator.
Okay. Now,
and then this matter includes the surface of this, ball, and this is our.
You just broke up for a second there, but we may be able to get back because I see Corey has come into the green room there, but he has a question. What are the properties of the UC particles? What is the transformation process that starts with annihilation and ends up creating something out of nothing? What is the transformation process?
I told that self-annihilation of UC particles, universe created particles, like Majorana fermions. Please take a look on the theory of Majorana, and you will take a look at the possible process for any self-annihilation of UC particles. Everything should be developed. I am not theoretical physicist to talk about self-annihilation of UC particles. Majorana, unfortunately, he passed away a long time ago. He could do it for me. But, it's the very good beginning for somebody to take care about self-annihilation process of the universe created particles based on Majorana theory.
Okay, here's a question from Professor Bute, who will be speaking to us at a later stage. I think black body radiation is due to random motion of electromagnetic sources. We proved it by using numerical resolution of Maxwell's equations. I suppose he's saying, is this in alignment with your work?
Let me refer to definition of black body radiation. You can take it in any place, not on Wikipedia, supposedly. Black body radiation, by definition, is thermodynamic equilibrium of photons with matter outside or inside of this cloud of photons. It is by definition. It's not my definition. It's well-known classical definitions, 120, 130 years old, this definition. That's why I don't want to change it. On the contrary, I want to come back to the classical physics, because photons with unique wavelengths, spreading wavelengths, losing energy, and so on and so on, I don't understand it at all. It's not classical physics. It's not physics at all. and nevertheless, it's the main stone for Big Bang model. Microwave background radiation is a confirmation and proof of Big Bang model. Wrong, absolutely wrong.
Oh, okay. Well, we may be able to come back to questions if there's some time at the end after we've gone through the more detailed discussion. I think Shockwave said somewhere that your theory is so complicated that it should be rejected on the basis of Occam's razor. Well, I think that's a bit of a non sequitur, actually.
No, let me comment. Let me comment. In my view, general relativity is so complicated that nobody can understand it instead of mathematicians only. My model is physical model. It's based on a classical physics. And if you guys know classical physics, it will be very easy for you to understand my model. Advantage of my model is not creating something new. On the contrary, I took the best, lost, great, genius ideas from the history of classical physics, and I recovered them in my model and put additional hypotheses. That's it. I insist on top. I'm sorry?
I dare say that might be one reason why it has appealed to a number of us, including myself. You know, we found it quite interesting to delve into. So thank you for that. Now, the green room people, a number of them their videos are off and they're muted and so on. If you'd like to, you've put it on, except Cornelis. So I'll probably get to you all, actually. I think we almost have time, but if anybody wants to come in immediately, just raise his hand or wave. No. And okay, yes, Corey is there. Okay. You're up now, Corey.
Well, I haven't got too much formally, but I have to go pretty quick, so I have to jump in here anyway.
Okay, because we don't have that much time, but go on.
Yeah, but basically, look, the transformation of UC particles to annihilation, and annihilation, forming matter particles, is a mystical thing. It's just as it happens, but it's like they annihilate, they disappear into space, and then they come back and reform into matter particles. That's what it is. And he said go to it's a marijuana experiment or something like that as an explanation. And I haven't looked at that at all. But first you have to understand what the UC particle properties are. I mean, there's not even a description of what a UC particle's property is. It's just a UC particle. And
so have you got more detail on that, Vladimir?
Sorry, there is no only names. I put fermions and bosons. Everybody knows what the difference between them. I put rest energies for them. Standard points, very good calculated. I put the next very important point, the self-annihilation of them. And self-annihilation doesn't mean that they will appear one more time. You forgot the main point of my model. Creation of new particles by the universe continuously. Instead of disappear these two particles, it will be two more from universe. You don't need to recover them. On the contrary, as a result of self-annihilation, you have some gamma radiation, you have in the new matter, even a standard, our ordinary matter, protons, electrons, and all this stuff, but you don't need to go back. Self-annihilation means only process in one way to create new particles, new matter, and so on and so on. But instead of these lost particles, you will get new particles from the eternal universe. That's why, and what is important, I put even weak interaction of these particles with matter. Unfortunately, lack of time didn't give me a chance to tell me what does it mean, this weak interaction, because even, in a standard model, there are so named WIMP, with weak interaction massive particles. but they didn't give even the numbers for weak interaction. I introduced weak interaction. I showed what is the value of it, what is the parameters of it, and so on and so on. But to put all my knowledge in 1 hour review, it's very difficult. That's why I didn't talk about this issue this time. I will talk about maybe next time about the weak interaction and all the parameters of this universe created particle.
Okay, I would suggest that's where we start, is one of your concepts, because you hit about a million things during this conference, and you always hit a million things during this conference, and it never ties together. So I think we need to take it a lot smaller steps and have a lot more discussion on the details of it, because just to say the particle is there, it disappears, and obviously the particle is has energy content, correct? And so this energy disappears into the ether, into something. Somehow it disappears into something, and it comes back together as a different particle. Now that's
no. I told you one more time. There is no back way. There are new particles
wait a minute.
coming from
You
universe.
just said it annihilates. Annihilate is out. It disappears.
These
Not
two
coming
particles
together.
now disappeared, but not disappeared. They created energy. They created other particles of ordinary matter, and so on and so on. They don't disappear. As a result of this self-annihilation, you have some new products.
It's not annihilation, it's transformation then. I would not call it annihilation, not annihilation. That's ludicrous, because annihilation means it disappeared. So that would...
We have electron positron annihilation. Disappeared, okay, particles disappeared, but you have your energy.
They can't disappear, because then they can't create something out of nothing. It has to be a transformation. Okay. It's a transformation process.
Some of these details.
That makes sense. I have to go, though. Thank you.
Okay, thank you very much, Corey. I might just say that some of these details about terminology and even a bit of a post-mortem on some of the concepts today, I think they might be addressed tomorrow during the discussion of the cosmology, which unfortunately I'm going to be away tomorrow, so I myself I don't think I'll be able to contribute to that. But just to point that out. Now, there's some private chat. Let me just see, is anything urgent here? Yeah. Actually, Jim has mentioned a couple of things. He said both. I'm not sure if he means Vladimir's and the Big Bang are creationist, in that Big Bang versus small puff. Weak interaction is said to be decomposition of neutrons, which is not understood in this talk. Let's get the man himself up to say exactly what you're getting at, Jim, there, if you would, please.
Well, one thing which I'm not clear on is that in today's talk and in previous talks, Vlad was talking about a beginning of the universe, but in today's talk, he's talking about an eternal universe, and quote unquote, neither a beginning nor an end. So which is it? Did the universe begin at a certain time, as all of your calculations seem to target, or is it, or is that not the case? This seems to be contradictory in my mind, at least.
Yes, sir. As for the eternal universe, there is neither beginning nor end. It's exactly what steady state theory told, and I'm telling the same. We know nothing about the eternal universe. There is neither time, neither space, neither beginning, neither is end. It's eternal universe. That's why we have the beginning of the world, not of the ether or of the eternal universe. It's eternal. It's a creator only. There is only one property of this creation. There is a creator, eternal universe, without any other properties. Don't ascribe to the eternal universe anything. Beginning, end, property, space, time, nothing. It's a creator only. That's it.
I think this has confused a number of people, including myself, Jim. The use of the term world where we might have used universe, and then the question of the universe coming in. So unless I'm misunderstanding the situation, the universe is everything. So maybe by definition, it has always been there. It's eternal. But the world is I don't know. People might have said, "Oh, the observable universe," or the material universe.
No. Ian, let me make a comment for you. Even Lethargian told there are some particles from another universe. It will be a mixture. Which universe you mean? Another universe, in his words, it's my eternal universe. And universe we observe with you is the world. Because if it will be universe and the another universe, how I can differ them from each other? In my talks, I will talk about the universe, and then it's the same universe or it's another universe. On the contrary, I put strong definition. There is the universe, and this is support the ideas of Lethargy, and not only him, some other, Jeans and all the other guys, That's why you must split them. The universe, creator only, and the world we live in.
And you don't use terms, Vladimir, like or conceptions of things like multiverses. You don't use that.
No, multiverses, no, because it's a theoretical mathematical models, but it might be parallel worlds. There is such a model, and maybe somebody who works with parallel models, parallel worlds, they can take my model, because inside of this hypersphere world, we can put at least 3 different observable worlds, but it's 3 different stories. But all the same, because hypersphere, it's a homogeneous and isotropic. There is no difference between our place in the world and some other place of the world. That's why it might be parallel, might be, but no multiverse. Because multiverse, it is only imaginations, mathematical equations, and that's it.
And so, some of the listeners might be just interested in the hypersphere, but this whole concept has been dealt with in more detail in your other talks, actually. The sort of Riemannian type of ideas, the hypersphere. Okay, Jim, do you want to come back further, or is that cool?
Well, 8 different presentations with different details.
Apparently, the beginning of our universe as we know it today started with the very first ensemble. This is a quote from Vlad, very first ensemble. And he gives a time when that occurred. And I call it the small puff, that created this first ensemble, and it's small compared to the Big Bang. So we have a small puff. And this is
by the way, I do like
I wonder what he adopt that.
I like it.
Yeah, you might have
after your explanation, what does it mean, small puff? I like it because it's small. You're absolutely right. The very ensemble particles, each of one. Oh, come on. Okay,
well,
good.
It may not have a ring as good as Let There Be Light, but Let There Be a Small Puff, or Let There Be an Ensemble. There's too many syllables in that to really have a good creationist ring. So I'm wondering, what kind of what do you expect, Vlad, in the coming years, if we want to speculate, that we might discover or see that might substantiate this idea of a small puff, or as you say, quote unquote, the very first ensemble? What would we see? Would we see, as Cornelius just stated, a blank universe with just one little point of light somewhere, and that's the very first ensemble, or what?
To see the very first ensemble, 14.226 billion light years, I don't know how to do it. And what is important? Sensitivity. Of course, in dark epoch, invisible epoch, for 0.44 billion years, we have ensembles, a lot of different and samples of these particles, and you can see some products. I mean, protons, electrons. You can see creation of universe-created matter, cause of superclusters, and all this stuff. And by the way, we can see them, but not as early as the beginning. We can see something, in my view, in my imaginations, that by infrared infrared astronomy, we can see even the beginning of our luminous epoch. Before luminous epoch, we have all these particles. We have interactions between them, self-annihilation between them, but we have only radiations. We don't have luminous objects. Luminous objects will appear later. That's why my imagination, and I told already in one of my papers, then with infrared astronomy, we can look at the beginning of the luminous epoch. Before luminous epoch, we can see some radiations, and there is no luminous epoch at all.
If I may jump in here,
but everything depends on sensitivity.
Ian, can I ask one more question?
Yeah. Okay, Jim, you had another point. Go ahead.
Just one more. Vlad is claiming that the so-called fundamental constant, capital G, is not constant. And I think this is one of the more challenging or controversial aspects of his presentation. And so if he can document that that G is in fact not constant, I think that would be of interest to many people in astronomy and cosmology. And I'll stop with that comment, because it could be there. I don't want to monopolize. Maybe there are other people that want to chime in here.
Can I?
Well, all I would say, Vladimir, is you might want to say a few words about this. At a later stage, you might want to give us more detail, give us another presentation on that. That would be welcome as well. Go ahead.
Okay, let me tell you, gravitational constant is not constant. It's not my idea. It's the Paul Dirac's idea in 1937. That's why I don't create this, knowledge. It's a very important point is that not even that gravitational constant is not constant. There is some kind of interconnectivity of cosmological parameters.
Okay, well, I don't want to cut you off, but I think that's
all of them
can
be
detail.
Measured. I'm sorry?
No, I'm just saying you're breaking up a little. So unfortunately, I think I chipped in there when you'd broken up. I'm not interrupting you, I hope. But this is actually an interesting question. The variability
yes, I
of
agree.
Parameters.
James,
maybe not just
interesting questions. First of all, the hypothesis of Paul Dirac, I implemented it not only for gravitational constant. I showed that the same behavior you can find for many cosmological parameters. I named them in my presentation. What is important? In principle, we can do maybe some experiments to measure gravitational constant with accuracy up to 8-9 digits, but we cannot do it. The main problem with gravitational constant that we cannot measure it accurately. Even now, we have maybe 4 digits after the comma, that's it. Instead of this one, Planck constant and some other fundamental constant, they measured up to the
I believe this is correct. That's correct information, that it's not a very constant, if you will, or difficult to measure with a high degree of accuracy, which raises questions in and of itself compared with other constants.
That's why, we cannot measure.
We haven't moved very much on from Cavendish's measurement, I suppose.
Yeah. That's why it's very difficult to measure. By the way, more than 200 measurements and no accuracy. And only the last years, and I reported this result by Chinese guys, they achieved accuracy at least 10 times better than it was before them. And I referred to them, but they measured this, gravitational constant a few years later than I calculated them. That's why it's simple. I have predicted in 2013 the value, and they confirmed this value 5 years later. Simple like this. But 5 digits only. They cannot do better. Nobody can do better. I'm sorry. That's why. Okay.
No, thanks very much. Jim, can we leave it at that, or do you want to make any last quick points?
Yes, and yes, I don't want to monopolize here. I just had a few questions. Hopefully there are other people who want to chime in here.
I want to bring Nick in because he's the other person in the green room who hasn't been invited in, and he hasn't raised his hand as yet. But Vladimir said that he was the man who, one of us in the CNPS, who actually first introduced him to us and helped him along. So I do want to give him
yeah.
But if you're quick, Jim, we have time for another quick. No,
thank you so much, James. See you tomorrow.
No, you're going, Jim. Okay.
See you tomorrow.
Sorry for cutting you off, but you can raise some of those points tomorrow, and I'll have a look at the recording. Don't worry about that. Thank you, Jim. Thank you. Nick, I've brought you up because I'm sure you have a couple of points you want to discuss with Vladimir.
Yes, I want to thank Vladimir, who I consider to be one of the great scientists of our era. And when I look at, I've had a lot of time to be exposed to his WUC theory, and I think basically the theory is very simple, which is wonderfully simple. However, when you're talking about all of cosmology and you have to explain all of the problems with the previous paradigm and then go through all of the evidence of why that was wrong and why yours is right, it's a huge topic. And I think that many of the questions raised were simply that in an hour or two, they didn't understand the entire scope of a new cosmology rather than there's any problem with the basic cosmology. So that's not a question. It's just a thank you to Vladimir for his giving us a new path to look at cosmology, a new paradigm.
Well, thank you for that response. And
Thank you very much,
I think
Nick. I'm so happy,
all
guys.
these other angles. I found today's presentation very, very useful, even though I've heard Vladimir obviously speak on quite a number of occasions before. Mm-hmm. So I think we need to look at these from the various angles. Before
Thank you so much, Nick. Thank you very much for introducing me to your society.
Yeah, well, thank you.
My pleasure.
Thank you for saying that again. And
I'm with you to meet you, have your help with the very first 8 presentations. You're the only one who read them before I started my presentation. And what is important, it was your recommendation to read my text, because if I will talk about it, nobody will understand at all, because it's too much. And it's unfortunately, it's the main problem with my cosmology. It's too much. Even 8 different presentations last year, it was not enough. Now I've done 2 more, and nevertheless, it's not enough. Thank you very much.
Well, you're always welcome to come back. And I do know that Nick in particular, and then maybe Harry, because I'm privy to the emails as well, made detailed comments, which unfortunately I wasn't in a position to do. But I hope in a small way that my general comments, were of some use. But I do know that Nick and Harry went into details which I was not in a position at the time to do. So,
can I talk, Harry? Can we see him? He's in the green room or not?
No, he's not. I would have brought him in had he. I have a feeling he may be lurking somewhere, but I don't see him. I don't see him in the green room. I don't see him surfacing and questions or anything. But he seems to come back the next day, and he seems to know everything that happened. I think this may be merely because he's looking at the recordings, but I think on one or two occasions we thought he wasn't actually present, and he was. So
Okay.
I've invited everybody in the green room in to speak.
Let me say a few words about Harry.
Yeah. So Nick, just before Vladimir does that, thank you very much, and we'll talk about this further. This is not the end by any means.
As I told you, about 1.5 years, I met Nick. We had a very good communication. As a result, I've done these 8 presentations the last year. Harry, he started communication with me 1 year ago, exactly May the last year. He asked me so good questions. I tried to answer all these questions, and I even changed some definitions. One of the definitions, before it was world universe model, he told, why world universe model? It's world universe cosmology. It was his proposal. And a lot of things, as an answer on his questions, I changed my even definitions. Before it was dark matter, right now universe created matter, because it's confusing. It's not dark. It's dark only if we have a telescopes only. But in some other wavelength range, we can see all these dark matter particles. That's why I changed even the title, the name of this particle, universe created particles. And it was everything due to his very good questions. Like Nick asked his questions, Harry asked his questions, and it was a new development of new notions and new basis for my model. Thanks them for very active influence on my model. Thank you them very much.
So thanks very much. So if I could just once more impose upon you, Vladimir, I'll give you the floor for as long as you want, a minute, 30 seconds, 2 minutes, 3 minutes, 4 minutes, just to summarize what we did today. And maybe you might have 1 or 2 observations in the light of questions or discussions that have occurred subsequently. And then I'll come back officially to close the meeting. I'll only take a moment or so to do that. So the floor is yours again, Vladimir.
Okay. First of all, thank you very much for coming, for asking good questions, because it's a very good learning curve for me. Answering your questions, it forced me to think about what I've done, how to change, how to clarify, and all this stuff. The very important issue, what I want to tell you, guys, I am not inviting you to understand all the model because it's too much for everybody. Even for me, it's too much. Why? And I can do it because I worked on this model for 24 years. For 12 years, I published my articles. I have about 40 articles published in Journal of High Energy Physics, Gravitation, and Cosmology. It took so long time for me to build this model and to try to put my model, my 24 years it was a very difficult task. And I didn't intend to clarify all these points at once. It's impossible. What I want to ask all of you, please, if you have an interest in some points of this model, in some steps of this model, in some phenomenon explained in this model, and you can put your knowledge to develop this point, I will be more than happy if you will follow my model. As I told in conclusion, it is not theory. It is not finished. It's only the basis for a new physics. It's impossible to develop new physics by one person. Even my 24 years, it was not enough. I invite all the physical community to jump on my model, to find their place in my model, and to develop one by one part of my model in a well-developed series. Please pay attention to my model. Take a look at it. Maybe you will find yourself developing one of the points of my model. I expect recognition of my model means that people, they refer to my model as it was done by basic model. I developed this and this and this, and I will be more than happy to see these publications. Thank you so much. I was very happy to report you today, and hopefully I will initiate your interest in my model and new development of different stages of my model. Thank you so much.
Well, thank you. And all I could do is echo those sentiments. I think Vladimir is certainly a very prolific researcher. He has the capacity. I know 24 years is not a short time, but he certainly has the capacity to produce a lot of information in a very short period of time and write these detailed papers, which he reads from slowly, as I say, so we can look at the text and we can see the constants and then he talks about them and so on. And I think it's been very, very useful. The more we hear about this, the clearer it becomes, certainly for my part, because I found it all a bit obscure initially, to be frank with you. But it's beginning to clarify itself in my mind. And I'd like to thank him as well. I mean, he has no problem in getting up, well, preparing for a 7 a.m. start in his time zone in California, I believe it is, on a Saturday morning. And that's to be much appreciated because he's done that on a number of occasions very, very early. And he does take all our questions. And actually, as he intimated himself, he, and I know this, he has not been reluctant to change things, to take, views expressed by us and others into account, and he indicated how maybe he changed his whole definitions of what was originally dark matter, but it could have been confused with the conventional dark matter, quite a different thing. So it's now UC and so on. So on behalf of the CNPS, we are certainly indebted to Vladimir for his constant meeting of our requirements and willingness to talk to us, as I say, giving 8 marathon sessions last year. And I'm sure, and I certainly hope that we haven't seen the end of him. He will be addressing us further on these related matters. So as I say, if any of this has confused you a little and we haven't been able to deal with it in the 2 hours of the presentation and questions, please feel free to contact us, and we'll either contact Vladimir directly if you can, or if not, through us, and we'll forward the discussion to Vladimir. So we've just gone over the time allotted to us. Thank you very much for all. I see most of the people coming on the social media, in fact, almost exclusively have come in through YouTube, not Facebook. Just an observation. But the Facebook is working as well. So please continue to follow us and make sure that you're attending these Saturday sessions. And thank you very much for the people in the green room as well. It does take a bit of organization to do that, to make sure you're available and so on. I know, for example, Corey had to leave a bit early, but everybody else is still here. And of course, most importantly, I'd like to thank, on behalf of the CNPS, Vladimir once again for having given us his time, his expertise, and for his patience in dealing with all the questions, and for his willingness to address any problems we have. Thanks so much, Ian. Well, my small services are at your disposal. I'd like to thank you very much, Vladimir, for having made this a memorable day, actually. And as I say, it's available for all time now. It's on our YouTube immediately after we hang up now. So goodbye, everybody. Enjoy the rest of the day, and we'll see you the next time. Good day.